Welcome to my Advanced Database Management System course. In this section, we discuss about installation and configuration of a database management system, DBMS, review system requirements, download and verify software, plan the installation, follow installation instructions. Let's enjoy. Installation and configuration of a database management system, DBMS, are critical steps in setting up a secure and reliable database environment. Here are some best practices for installing and configuring a DBMS. 1. Choose the right DBMS. Select a DBMS that best fits your requirements, taking into account factors such as scalability, performance, features, and compatibility with your existing infrastructure and applications. 2. Review system requirements. Before installation, review the system requirements for the chosen DBMS, including hardware specifications, operating system compatibility, disk space, memory, and processor requirements. 3. Download and verify software. Download the DBMS software from the official vendor website or a trusted source. Verify the integrity of the downloaded software by comparing its checksum or digital signature with the vendor's official checksum or signature. 4. Plan the installation. Plan the installation process, including selecting the installation directory, configuring network settings, choosing database options, and setting up authentication and access controls. 5. Follow installation instructions. Follow the installation instructions provided by the DBMS vendor, including running the installer program, accepting the license agreement, and specifying installation options, such as installation directory, components to install, and startup options. 6. Configure security settings. During installation, configure security settings, such as authentication methods, passwords, access controls, and encryption options to ensure the security of the database environment. 7. Enable encryption. Enable encryption options such as transparent data encryption, TDE, or SSL, TLS encryption to protect data at rest and in transit, safeguarding it from unauthorized access and data breaches. 8. Configure backup and recovery. Set up backup and recovery options to protect against data loss and ensure business continuity in the event of hardware failures, software errors, or security incidents. Configure backup schedules, retention policies, and storage locations. 9. Optimize performance. Configure performance settings, such as memory allocation, buffer pool size, cache size, and query optimization parameters to optimize database performance and ensure efficient use of system resources. 10. Apply security patches and updates. After installation, apply security patches and updates to the DBMS software and underlying operating system to address known vulnerabilities, security issues, and performance improvements. Establish a patch management process to ensure timely deployment of updates. 11. Test and validate installation. Test the installation and configuration of the DBMS by performing functionality tests, connectivity tests, and security checks. Validate that the database is accessible, responsive, and functioning as expected. 12. Document installation and configuration. Document the installation and configuration process, including installation steps, configuration settings, security policies, backup procedures, and any customizations made. Maintain up-to-date documentation for reference and troubleshooting purposes. By following these best practices for installation and configuration, you can ensure a smooth and secure deployment of your DBMS, minimizing the risk of security vulnerabilities, performance issues, and data loss. Additionally, regularly review and update the configuration settings and security measures to adapt to evolving requirements and mitigate emerging threats. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about database management system, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to Advanced Database Management System. In this section, we discuss about new SQL databases, CockroachDB, key features of new SQL databases, benefits of new SQL databases, challenges of new SQL databases, future trends in new SQL databases. Let's enjoy. Definition of new SQL. Characteristics of new SQL databases. Combines the benefits of traditional SQL databases with scalability and performance as NoSQL, ACID compliance, distributed and horizontally scalable architecture. Overview of CockroachDB features. Distributed SQL database, strong consistency, horizontal scalability, multi-active availability. Native representation of relationships, efficient traversal of complex networks, schema flexibility, support for ACID transactions. Combines scalability of NoSQL with ACID compliance SQL, simplified data management with SQL interface, high performance for both read and write operations, horizontal scalability without sacrificing consistency. Data modeling complexity, managing distributed transactions, performance tuning for distributed queries, operational complexity in managing distributed clusters. Comparison of new SQL with traditional SQL and NoSQL databases. Use cases where new SQL databases offer advantages over other approaches. Advances in distributed SQL query optimization. Integration with cloud-native technologies, example, Kubernetes. Predictions for the future evolution of new SQL databases. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to my Advanced Database Management System course. In this section, we discuss about multi-model databases, multiple data models, unified data management, flexibility and agility, interoperability. Let's enjoy. Multi-model databases are database systems that support multiple data models within a single integrated platform. Unlike traditional databases that are typically designed for a specific data model, e.g., relational, document, graph, multi-model databases offer flexibility and versatility by allowing users to work with different types of data models interchangeably. Here are some key characteristics and considerations of multi-model databases. Support for multiple data models. Multi-model databases support a variety of data models, including relational, document, graph, key value, and time series. This enables users to store and query different types of data using the most appropriate data model for their use case. Unified data management. Multi-model databases provide a unified platform for managing diverse types of data, eliminating the need for separate databases or specialized tools for each data model. This simplifies data management and reduces complexity for developers and administrators. Flexibility and agility. Multi-model databases offer flexibility and agility in data modeling and schema design. Users can choose the most suitable data model for their data and easily adapt to changing requirements without the need for schema migrations or data transformations. Interoperability. Multi-model databases enable seamless interoperability between different data models, allowing users to perform complex queries and analytics that span multiple data types. This promotes data integration and facilitates cross-domain analysis and insights generation. Scalability and performance. Multi-model databases are designed to scale horizontally and vertically to handle growing data volumes and user loads. They provide efficient indexing, query optimization, and distributed processing capabilities to ensure high performance and scalability across diverse workloads. Data consistency and integrity. Multi-model databases ensure data consistency and integrity across different data models through transaction support, ACD compliance, and data validation mechanisms. They maintain data consistency constraints and enforce referential integrity to preserve data quality. Use cases. Multi-model databases are well suited for a wide range of use cases that involve diverse data types and complex data relationships. Examples include content management systems, e-commerce platforms, social networks, IoT data processing, real-time analytics, and fraud detection. Developer productivity. Multi-model databases enhance developer productivity by providing a unified API and query language for accessing and manipulating data across different data models. This reduces the learning curve and allows developers to focus on application logic rather than data management intricacies. Integration with existing systems. Multi-model databases integrate seamlessly with existing systems and data sources, enabling organizations to leverage their existing investments in infrastructure and applications. They support data migration, replication, and synchronization with legacy databases and external data sources. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to my Advanced Database Management System course. In this section, we discuss about monitoring and alerting, monitoring tools, monitor key metrics, implement automated monitoring. Let's enjoy. Monitoring and alerting are essential components of database management, providing insights into system health, performance, and availability. Here are some best practices for monitoring and alerting in database management. 1. Define monitoring objectives. Define clear objectives and goals for monitoring, such as identifying performance bottlenecks, detecting anomalies, ensuring data availability, and meeting service level agreements, SLAs. 2. Select monitoring tools. Choose appropriate monitoring tools and solutions that meet the requirements of your database environment. Consider factors such as scalability, compatibility, features, and ease of use when selecting monitoring tools. 3. Monitor key metrics. Monitor key performance metrics such as CPU utilization, memory usage, disk I/O, network throughput, query latency, transaction throughput, and database connections. Track these metrics over time to identify trends and deviations from normal behavior. 4. Establish baselines. Establish baseline performance metrics for your database system under normal operating conditions. Use historical data and performance benchmarks to define baseline thresholds and detect deviations from expected performance levels. 5. Implement automated monitoring. Implement automated monitoring solutions that continuously collect and analyze performance data in real time. Use automated monitoring scripts, agents, or monitoring platforms to streamline data collection, analysis, and reporting processes. 6. Set up alerts. Configure alerts and notifications to proactively alert administrators and stakeholders about performance issues, anomalies, and potential problems. Set up alert thresholds based on baseline metrics, performance objectives, and criticality of the monitored parameters. 7. Define escalation policies. Define escalation policies and procedures for handling alerts and incidents. Establish clear roles, responsibilities, and escalation paths for responding to alerts, diagnosing problems, and resolving issues in a timely manner. 8. Monitor database logs. Monitor database logs, error logs, and audit logs for warning signs, error messages, and security events. Analyze log data to identify performance bottlenecks, security breaches, and operational issues that require attention. 9. Correlate metrics and events. Correlate performance metrics with system events, database activities, and workload patterns to gain deeper insights into performance trends and root causes of issues. Use correlation analysis to identify cause and effect relationships between different metrics and events. Conduct capacity planning. Use monitoring data and performance trends to conduct capacity planning and resource allocation. Forecast future capacity requirements based on growth projections, workload patterns, and performance trends to ensure scalability and optimal resource utilization. Regularly review and tune alerts. Regularly review alerting configurations, alert thresholds, and alerting rules to ensure that they remain relevant and effective. Fine-tune alerting parameters based on feedback, changes in workload, and evolving business requirements. 12. Document monitoring procedures. Document monitoring procedures, alerting configurations, and incident response workflows for reference and knowledge sharing. Maintain up-to-date documentation of monitoring tools, metrics, alerts, and escalation procedures. By following these best practices for monitoring and alerting, database administrators can proactively detect, diagnose, and resolve performance issues, ensure data availability, and maintain the health and reliability of their database systems. Continuous monitoring, analysis, and optimization are essential for effectively managing database environments and meeting the performance objectives of the organization. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to my Advanced Database Management System course. In this section, we discuss about machine learning and AI in databases, natural language processing, NLP, data security and privacy, automated insights and data exploration. Let's enjoy. Machine learning, ML, and artificial intelligence, AI, are increasingly being integrated into databases to enhance their capabilities and provide more intelligent data management and analytics solutions. Here are some ways ML and AI are used in databases. Query optimization. ML algorithms can analyze query patterns and historical query execution data to optimize query performance. By learning from past query executions, ML models can suggest better query plans, indexing strategies, and database configurations to improve overall system performance. Recommendation systems. AI algorithms such as collaborative filtering and content-based filtering are used to build recommendation systems in databases. These systems analyze user behavior and preferences stored in the database to generate personalized recommendations for products, services, or content. Natural language processing NLP techniques enable databases to understand and process natural language queries and commands. By incorporating NLP capabilities, databases can support voice search, conversational interfaces, and text-based query processing, making data access more intuitive and user-friendly. Automated data management. AI-driven automation tools can assist in data management tasks such as data cleaning, data integration, and data categorization. ML algorithms can learn from historical data management activities to automate repetitive tasks and improve data quality and consistency. Data security and privacy. ML and AI techniques are used to enhance data security and privacy in databases. AI-powered systems can analyze access patterns and user behavior to detect potential security threats and anomalies. Additionally, NL models can help in data anonymization, encryption, and compliance with privacy regulations such as GDPR. Optimized resource allocation. ML algorithms can analyze resource usage patterns in databases and predict future resource requirements. By optimizing resource allocation, databases can ensure efficient utilization of computing resources such as CPU, memory, and storage, leading to cost savings and improved performance. Automated insights and data exploration. AI-driven data exploration tools can analyze large datasets stored in databases and automatically generate insights, trends, and patterns. These tools enable users to uncover hidden insights and make data-driven decisions without requiring extensive manual analysis. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to Advanced Database Management System. In this section, we discuss about primary keys and foreign keys. Let's enjoy. Keys, specifically primary keys and foreign keys, are crucial components in relational database design. They establish relationships between tables and ensure data integrity. Here's an explanation of primary keys and foreign keys. Primary key. A primary key is a column or a set of columns in a table that uniquely identifies each record in the table. It must have a unique value for each row, and it cannot contain null values. Primary keys are defined when creating the table using the primary key constraint. By default, primary keys also typically have an associated index for fast data retrieval. Example, in a table of employees, the employee ID column could be designated as the primary key. Foreign key. A foreign key is a column or a set of columns in one table that establishes a link to a primary key in another table. It represents a relationship between two tables, where the values in the foreign key columns of one table match the values in the primary key columns of another table. Foreign keys enforce referential integrity, ensuring that values in the referencing table's foreign key columns exist in the referenced table's primary key columns. Foreign keys are defined using the foreign key constraint. Example, in a table of orders, a foreign key referencing the customer ID column in the customers table establishes a relationship between orders and customers. Create table employees. Employee ID, int primary key, first name varchar50, last name varchar50, department ID int, foreign key, department ID references departments, department ID. Create table departments, department ID int, primary key, department name varchar50, for. In this example, in the employees table, employee ID is designated as the primary key. The departments table also has a primary key, department ID. The department ID column in the employees table serves as a foreign key that references the department ID column in the departments table, establishing a relationship between the two tables. This ensures that every value in the department ID column of the employees table corresponds to a valid department ID in the departments table. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to my Advanced Database Management System course. In this section, we discuss about limiting results. Let's enjoy. Limiting the number of results returned by a SQL query is achieved using the limit clause. The limit clause allows you to specify the maximum number of rows to return in the result set. Here's how you can use the limit clause in SQL. Select column 1, column 2, exclamation mark. From table name, limit number of rows. Column 1, column 2, exclamation mark. You want to retrieve data from. You can specify one or more columns separated by commas. If you want to retrieve all columns, you can use star, table name, the name of the table from which you want to retrieve data. Number of rows, the maximum number of rows to return in the result set. Here are some examples of using the limit clause to limit the number of results in SQL. Retrieve the first 10 rows from a table. Select star, from students, limit 10. Retrieve the first 5 rows from a table sorted by age in descending order. Select star, from students, order by age DESC, limit 5. Retrieve the top 3 highest paid employees. Select star from employees, order by salary DES, limit 3. Retrieve the first 20 orders placed in the year 2022. Select star from orders where year order date equals 2022, limit 20. The limit clause is particularly useful when dealing with large data sets or when you only need to retrieve a subset of rows from a table. It allows you to control the size of the result set and improve query performance by reducing the amount of data processed by the database engine. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to Advanced Database Management System. In this section, we discuss about key value stores. Redis, key features of key value stores, benefits of key value stores, best practices for working with key value stores, future trends in key value stores. Let's enjoy. Definition of key value stores, characteristics of key value databases, basic data model, pairs of keys and associated values, simplicity and high performance, scalability and fault tolerance. Overview of Redis data model in Redis, key value pairs, features, in-memory data storage, support for various data types, strings, lists, sets, etc., pub-sub messaging, built-in replication and clustering. Simple data model, keys mapped to values, high performance for read and write operations, in-memory and disk-based storage options, support for data types beyond strings, e.g. lists, sets, hashes. High performance and low latency, scalability for handling large datasets, simple data model and ease of use, versatility in supporting various use cases. Comparison of key value and relational data models. When to choose a key value store over a relational database. Choosing appropriate data structures for keys and values, optimizing cache eviction policies, handling data persistence and backups, monitoring and performance tuning. Advances in in-memory computing technologies. integration with other data processing frameworks, e.g., Apache Spark, predictions for the future of key-value databases. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to Advanced Database Management System. In this section, we discuss about join operations, types of joins, inner join, left join, right join, full join, cross join. Let's enjoy. Join operations in SQL. Join operations allow you to retrieve data from multiple related tables based on a related column. Same types of joins. Inner join returns only rows that have matching values in both tables. Select e.name, d.department name from employees E. Inner join departments D on e-department ID equals DID. Left join or left outer join returns all rows from the left table and matched rows from the right table. Unmatched rows from the right will have null. Select e-name, d.department name from employees E left join departments D on e-department ID equals DID. Right join or right outer join returns all rows from the right table and matched rows from the left table. Select e.name, d.department name from employees E right join departments D on e-department ID equals d.id. Full join or full outer join returns all rows when there is a match in one of the tables. SQL select e.name, d.department name from employees E full join departments D on e-department ID equals d.id. Cross join returns the Cartesian product of both tables, every combination. Select E name, P project name from employees E, cross join projects P. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to my Advanced Database Management System course. In this section, we discuss about isolation levels, read uncommitted, read committed, repeatable read, serializable. Let's enjoy. Isolation levels define the degree to which the transactions in a database system are isolated from each other. Different isolation levels provide different trade-offs between data consistency and concurrency. The commonly used isolation levels are defined by the SQL standard, and they include read uncommitted. In the read uncommitted isolation level, transactions are not isolated from each other. This means that a transaction can see uncommitted changes made by other transactions. Read uncommitted provides the highest degree of concurrency, but sacrifices data consistency, since transactions can read dirty data that has not been committed yet. Read committed. In the read committed isolation level, transactions can only see committed data. This means that a transaction cannot read data that has been modified but not yet committed by other transactions. Read committed isolation level prevents dirty reads but allows non-repeatable reads and phantom reads. Repeatable read. In the repeatable read isolation level, a transaction sees a consistent snapshot of the database at the time the transaction starts. This means that any data read by the transaction remains unchanged during the transaction's lifetime, even if other transactions modify or delete the data. Repeatable read prevents dirty reads and non-repeatable reads, but allows phantom reads. Serializable. In the serializable isolation level, transactions are completely isolated from each other. This means that transactions execute as if they were the only transactions running on the database. Serializable provides the highest level of data consistency, but can lead to decreased concurrency and increased contention due to locking. Snapshot isolation. Snapshot isolation is a variation of the repeatable read isolation level that provides a consistent snapshot of the database at the time the transaction starts. However, unlike repeatable read, snapshot isolation allows other transactions to modify the data concurrently. Each transaction sees a consistent snapshot of the database, but it may see different versions of the data modified by other transactions. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to my Advanced Database Management System course. In this section, we discuss about indexing and query optimization, types of indexes, benefits of indexing, query optimization techniques for query optimization. Let's enjoy. Indexing and query optimization are essential techniques used to improve the performance of database systems by speeding up data retrieval and query processing. Here's an overview of indexing and query optimization. Indexing. What is an index? An index is a data structure associated with a database table that allows for efficient retrieval of data based on certain columns or expressions. Indexes provide a quick lookup mechanism, similar to the index of a book, allowing the database to locate specific rows quickly without scanning the entire table. Types of indexes. B-tree index. The most common type of index used in database systems. It stores keys in sorted order, allowing for efficient range queries and equality searches. Hash index uses a hash function to map keys to index entries, providing constant time lookup for equality searches but not supporting range queries. Bitmap index, suitable for columns with low cardinality, where each bit in the index represents the presence or absence of a value. Full text index, designed for efficient text searches, supporting operations such as word searches and phrase searches. Spatial index, optimized for spatial data types, enabling efficient retrieval of spatial objects based on their geometric properties. Creating indexes. Indexes can be created using SQL commands, such as create index. You specify the table and column S to be indexed, and the database system creates the index accordingly. Benefits of indexing. Improved query performance. Indexes speed up data retrieval operations, especially for columns frequently used in search conditions or join predicates. Enhanced data integrity. Unique indexes enforce uniqueness constraints, preventing duplicate values in indexed columns. Support for constraints. Indexes can be used to enforce primary key, unique key, and foreign key constraints. What is query optimization? Query optimization is the process of improving the performance of database queries by selecting efficient execution plans. The goal is to minimize query execution time, reduce resource consumption, and improve overall system efficiency. Query execution plans. A query execution plan is a sequence of operations performed by the database system to retrieve and process data requested by a query. The optimizer generates multiple execution plans and selects the one with the lowest cost based on factors such as access methods, join algorithms, and index usage. Techniques for query optimization. Cost-based optimization uses statistical information and cost models to estimate the cost of executing different query plans and selects the plan with the lowest estimated cost. Query rewriting transforms the original query into an equivalent form that can be executed more efficiently. Techniques include predicate pushdown, join reordering, and subquery optimization. Index usage. identifies and selects appropriate indexes to access data efficiently. The optimizer considers index selectivity, cardinality, and access path options. For example, index scans, index seeks, join optimization determines the most efficient join order and join algorithms. For example, nested loop join, hash join, merge join, based on the size of the tables, join conditions, and available indexes. Parallel execution executes queries in parallel across multiple CPU cores or nodes to exploit parallelism and reduce query execution time. Monitoring and tuning. Query performance should be regularly monitored using tools such as database performance monitors and profiler tools. Performance bottlenecks can be identified and query optimization techniques can be applied to address them. This includes creating or modifying indexes, rewriting queries, or adjusting database configuration parameters. Effective indexing and query optimization play a crucial role in improving database performance, reducing query response times, and enhancing overall system scalability and efficiency. By utilizing appropriate indexing strategies and optimizing query execution plans, database administrators can ensure optimal performance and responsiveness of their database systems. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to Advanced Database Management System. In this section, we discuss about in-memory databases, implementation considerations, challenges and limitations, future trends. Let's enjoy. Overview of the architecture, data storage in main memory, mechanisms for durability and persistence, snapshots, transaction logging, replication, memory requirements, data persistence strategies, scalability options, integration with existing systems, memory requirements, data persistence strategies, scalability options, integration with existing systems, memory constraints, cost considerations, data persistence complexities, integration challenges with existing infrastructure, continued adoption and growth of in-memory databases, advances in memory technology, for example, non-volatile memory, integration with emerging technologies, for example, AI, edge computing. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to Advanced Database Management System. In this section, we discuss about graph databases, Neo4j benefits of graph databases, key features of graph databases, best practices for working with graph databases, future trends in graph databases. Let's enjoy. Definition of graph databases, characteristics of graph databases, data represented as nodes, edges, and properties, optimized for traversing relationships, use cases, social networks, recommendation engines, fraud detection. Introduction to Neo4j, data model in Neo4j, nodes, relationships, properties, features, native graph storage and processing, Cipher query language, ACID compliance, high availability clustering, native representation of relationships, efficient traversal of complex networks, schema flexibility, support for ACID transactions, natural representation of connected data, high performance for relationship-heavy queries, flexible schema evolution, powerful graph algorithms and analytics, comparison of graph and relational data models, use cases where graph databases excel over relational databases, effective data modeling strategies for graph structures, optimizing queries and indexes, cluster configuration and optimization. Monitoring and maintenance practices. Advances in graph algorithms and analytics. Integration with machine learning and AI technologies. Predictions for the future evolution of graph databases. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to my Advanced Database Management System course. In this section, we discuss about edge computing databases, proximity to data sources, low latency processing, offline operation, distributed architecture, resource efficiency. Let's enjoy. Edge computing databases are database systems specifically designed to operate at the edge of the network, closer to the data sources and end users. These databases are optimized for low latency, high throughput data processing, and storage in edge computing environments. Here are some key characteristics and considerations of edge computing databases. Proximity to data sources. Edge computing databases are deployed closer to the data sources, such as IoT devices, sensors, and edge servers. This proximity reduces latency and network bandwidth usage by processing and storing data locally at the edge. Low latency processing. Edge computing databases prioritize low latency data processing to support real-time applications and services at the edge. They minimize data round-trip times and response times by executing data processing tasks locally without relying on centralized cloud servers. Offline operation. Edge computing databases are designed to operate offline or with intermittent connectivity. As edge environments may experience network disruptions or limited connectivity, they provide mechanisms for local data storage, caching, and synchronization to ensure data availability and continuity of service. Distributed architecture. Edge computing databases employ distributed architectures that span multiple edge nodes or devices. They support data replication, synchronization, and consistency mechanisms to maintain data integrity and availability across distributed edge environments. Resource efficiency. Edge computing databases are optimized for resource-constrained edge devices with limited compute, memory, and storage capabilities. They minimize resource usage by employing lightweight data storage formats, efficient indexing structures, and data compression techniques. Edge analytics. Edge computing databases support real-time analytics and data processing at the edge, enabling edge devices to analyze and act on data locally without the need to transmit data to centralized servers. This enables faster decision-making and reduces reliance on cloud-based analytics. Security and privacy. Edge computing databases implement robust security features to protect data at the edge, including encryption, access controls, authentication, and data anonymization. They ensure data privacy and compliance with regulatory requirements, such as GDPR and HIPAA, in edge computing environments. Integration with cloud services. Edge computing databases seamlessly integrate with cloud services and centralized data platforms, enabling hybrid cloud edge deployments. They support data synchronization, replication, and streaming between edge devices and cloud-based databases for centralized data analysis and storage. Edge cloud orchestration. Edge computing databases work in conjunction with edge cloud orchestration platforms, such as Kubernetes or Docker Swarm, to manage and orchestrate edge computing resources. They support containerized deployments and microservices architectures for scalable and flexible edge deployments. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to Advanced Database Management System. In this section, we discuss about document stores, MongoDB, key features of document stores, benefits of document stores versus relational databases, best practices for working with document stores. Let's enjoy. Definition of document stores. Characteristics of document-oriented databases. Store data in semi-structured documents, e.g., JSON, BSON. Schema flexibility. Rich querying capabilities. Overview of MongoDB document structure in MongoDB features. Horizontal scalability, replication and high availability. Rich query language, MongoDB query language. Schema flexibility, nested and hierarchical data structures. Support for arrays and complex data types. Embedded documents. Flexibility in schema design. Horizontal scalability. High performance for read-heavy workloads. Native support for JSON, BSON data types. Comparison of document-oriented and relational data models. When to choose a document store over a relational database. Designing efficient document schemas. Indexing strategies. Data modeling considerations. Handling complex queries. Evolution of document-oriented databases. Integration with other technologies, for example, AI, ML, blockchain. Predictions for the future of document store. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson. Welcome to my Advanced Database Management System course. In this section, we discuss about distributed databases and CAP theorem, partition tolerance, implications of the CAP theorem. Let's enjoy. Distributed databases are database systems that store data across multiple nodes or servers in a distributed manner. These databases are designed to handle large volumes of data and provide high availability and scalability. However, distributed databases face inherent challenges related to consistency, availability, and partition tolerance, as described by the CAP theorem. CAP theorem. The CAP theorem, also known as Brewer's theorem, states that in a distributed system, it is impossible to simultaneously achieve all three of the following guarantees. Consistency. Consistency refers to the guarantee that all nodes in the distributed system will have the same data at the same time. In other words, all read operations will return the most recent write value. Availability. Availability refers to the guarantee that every request made to a non-failing node in the system receives a response, regardless of the current state of the system. Partition tolerance. Partition tolerance refers to the system's ability to continue operating despite network partitions or communication failures between nodes. Network partitions can occur due to factors such as network outages, hardware failures, or software issues. According to the CAP theorem, in the event of a network partition, a distributed system must choose between ensuring either consistency, or availability, It is not possible to guarantee both. Implications of the CAP theorem. CA systems. Some distributed systems prioritize consistency and availability over partition tolerance. These systems sacrifice availability during network partitions to ensure strong consistency. Examples include traditional relational databases like MySQL configured in a single master replication setup. CP systems, other distributed systems, prioritize consistency and partition tolerance over availability. These systems maintain consistency even during network partitions, but may become temporarily unavailable. Examples include systems using consensus algorithms like Paxos or RAF. AP systems. Finally, some distributed systems prioritize availability and partition tolerance over strong consistency. These systems remain available during network partitions, but may provide eventual consistency, where different nodes may temporarily diverge in their views of the data. Examples include many NoSQL databases like Cassandra and DynamoDB. Considerations. Trade-offs. Designing distributed systems involves making trade-offs between consistency, availability, and partition tolerance based on the specific requirements of the application and the desired system properties. Tuning parameters. Distributed databases often provide configuration options that allow developers to adjust consistency, availability, and partition tolerance based on application needs. Quorum systems. Some distributed systems use quorum-based techniques to achieve a balance between consistency and availability during network partitions. By carefully configuring quorum settings, these systems can provide different levels of consistency and availability. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson.